Hi, my name is Anna Marie Picarillo, and I'm going to be talking about the history of gas law and some of their related equations. And I'm just going to dive a little bit more into how they were developed and who developed them. Alright, so Charles's law was able to investigate the relationship between the volume of a gas and its temperature. The law describes how gases tend to expand when heated. His finding states that V1 over T1 equals V2 over T2. So how this was discovered was he created a balloon that used hydrogen gas produced through an exothermic chemical reaction, and he would observe how this balloon inflated. He did not cool it down before charging it into the balloon. He found that after some time, the volume of the balloon had deflated. He also fixed this system by cooling the hydrogen before charging it into the balloon and achieved the first manned balloon flight. So that's how he discovered that the volume is related to the temperature. Alright, so kinetic molecular theory. This was discovered by Rudolf Clausius. Or I think that's how you say it. He developed the kinetic theory of gases into a more sophisticated and systematic form. He described how molecule properties relate to the macroscopic behaviors of an ideal gas. Therefore, physical properties of gases can be explained in terms of particles. So the development comes from observations that scientists made about gases to explain macroscopic properties. So this wasn't developed by nearly one experiment. It was a conclusion based on previous research and findings. These three things being that gas is composed of a large number of identical molecules moving in random directions, separated by distances that are large compared with their size. Another conclusion of this theory is that molecules undergo perfect elastic collisions with each other and the walls of the container. Another one is that the transfer of kinetic energy between molecules is heat. So these are some of the conclusions of these equations or assumptions. Alright, so moving on to Dalton's law. His interest in weather motivated him to study gases. He was the first to observe that the pressure of a mixture of gases is the sum of pressures of various gases in the mixture. Dalton's law created PT, standing for the pressure total, equals P1 plus P2 plus P3 plus all the pressures of the system. So that's represented over here in this equation. So how it was discovered, he derived the law of partial pressures from his experiments measuring on the amount of water vapor that could be absorbed by air at different temperatures. So he did use an experiment measuring these water vapors, and that's how it was discovered. Alright, Gay-Lussac's law. So one of his laws relates the pressure of gas to its temperature, and the other combines volume law and relates gaseous reactions and the volume ratios of reactant and product gases. So this was discovered while he was building an air thermometer. The pressure of gases of fixed masses and fixed volume is directly proportional to the gas's absolute temperature, and you could see a model right over here. Alright, so I'm going to talk a little bit about Avogadro's law. So he extended the work of Gay-Lussac by proposing that gases consist of very small particles called molecules. His law states that equal volumes of gases under the same conditions of temperature and air pressure contain equal numbers of molecules. So this was developed and simultaneously proved, not exactly by an experiment like one of these previous laws, and it was proved by evidence that showed equal volumes is equal numbers, and the hypothesis was proved using a number of laws and a number of experiments, so it was more of a conclusion. Alright, I'm going to talk a little bit about Graham's law. So he studied the way gases mix by diffusion as well as how they infuse through a square semi-permeable barrier. He was able to show that the rate of infusion is inversely proportional to the square root of the molecular mass of the gas. So this is shown in the equation right over here. So how this was discovered, Grimm went on to study the diffusion of substances in a solution, and the process made the discovery that some apparent solutions actually are suspensions of particle too large to pass through a Parchment filter. All right, and that is the last law and how the laws are described.